I'd like to welcome our new sponsor, Couchbase. Couchbase is an open source, NoSQL document and key value store database. Requires no external cache, supports SQL and analytical queries for JSON data. Couchbase supports technologies like Kubernetes, Java, .NET, JavaScript, Go, and Python. Download it, give it a try at couchbase.com/HanselMinutes. That's couchbase.com/HanselMinutes. And I'll remind you that when you support our sponsors, you support this show. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Ralph Hempel, who's a senior manager at the Electronics Firmware Department of the LEGO Group. How are you, sir?
I'm doing great, Scott. Good to meet you.
The Legos in the house here are just for the kids. You can't judge me. I'm just storing them for the children.
Of course. And they have full access to it, and they never come into your room, do they?
There's some paperwork they have to fill out. I check them out like a librarian, It's
yeah, that's awesome.
Just because it's their education. It's the future of the value of their education, right? It's an investment, really.
Yeah, you need to safeguard that.
You really do. So you are an electronics and firmware engineer. You've been one for many years. Are you primarily embedded systems in your career?
Yep, it's pretty much straight ahead embedded systems. If it's not on the metal, I'm not that I'm not interested, but it's just something that I don't need to worry about.
Mm-hmm. So you've been doing that for almost 30 years, and has it been? Forgive my ignorance. I'm going to ask ignorant questions because that's my superpower. Has it been basically C code for 30 years, talking to the metal of these systems?
Well, yeah, I guess it's, if I look at the full span, it's been almost 40 years, I'm ashamed to say. But it started out in assembler language. Actually, I learned to program on an HP 41CV calculator. So that's how far back that goes. So you start in assembler, but really for the last 35 years, it's been in C and embedded C. Yeah.
Mm-hmm. And when we look at the up-leveling of the technology that is available to children, the idea that a child could have a Lego system that is itself a computer. What is the thing that has happened over the last 40 years that has enabled that? Is it just chips get faster, things get smaller? Why is it possible that the PC that you learned on is probably less powerful than one of the new Lego elements that you're working on?
I think that's a fair statement. So LEGO MINDSTORMS has gone, we've got pretty much a 20-year history, and I've been involved since the beginning on that one. So if you remember the yellow RCX device, that was running on I think, I can't remember the speed exactly, but it was a dumb little 8-bit microprocessor. Then the NXT, which was the second generation, that was basically an ARM7, so up to 32-bit. The EV3, which I founded EV3 Dev, which is a full Linux distribution that runs on the EV3. That's a full ARM9, and it's actually rocking pretty hard, that one. And now we've got Spike Prime that we just released this January, and we're back down to an ARM on that one. But the cool thing is that we've got MicroPython, and I think that's one of the most amazing thing that's happened in the last 5 years is the amount of effort that's gone to put MicroPython on a microprocessor. So you can get Pi boards. Adafruit has a bunch of different boards, and I'm really glad to say that Lego Spike Prime has MicroPython as kind of the core way of doing things. So you can actually program it, plug it in over USB, and it looks like a serial terminal, and you can just clack away and put Python code right on there.
Traditionally, when I've seen embedded systems in toys, I have found in the past that the companies tend to put a friendly face on it. It's like, here's our thing, here's our toy, like here's an EV3, for example, which is a wonderful Lego kit that you can still get today. And then here is our IDE, right, our integrated development environment for children. Do you think that there's a movement towards being able to say, all right, here's a text file, here's a USB drive, just start coding, and when does one stop and when does one end?
Yeah, that's a really good question. I think putting a friendly face on programming is something that Lego has always been really interested in doing. You can see that if it's drag and drop, if it's a GUI, that must mean it's kid friendly, right? And that bar was really raised for me when I watched some young kids, the Session Brothers, who are really big EV3 fans and now Spike Prime fans as well. They're really quite famous in the FLL world. These little guys picked up Python programming just like that. So it's really not just for kids, graphical programming. So we're seeing a lot more of a drive towards text-based programming as well. But at the same time, Spike Prime does support Scratch programming. So you've got a nice Scratchy interface on your GUI. And then if you really want to, you can lift the lid and program in MicroPython.
I think that's really, really significant. I mean, Spike Prime is a very accessible environment where a young kid, a 9, 10, 11-year-old can look at it and go, I know this is Lego, and then I can start adding in the more interactive elements. But was there a conscious decision to say, if someone wants to pop the hood and look at the engine and really, move fast and break things, we are going to allow that, as opposed to maybe in the past, not at Lego, but at other companies where it's don't hack our things. You're really encouraging that. You're allowing people to pop the hood and start playing at the low level.
Yep. I think that's, I'm not so sure it was a conscious decision as kind of a happy accident. I've been involved with LEGO MINDSTORMS components or elements for the last 20 years, not officially with LEGO, but as an AFOL. That's an adult fan of LEGO, and it's a term that you've obviously heard from other people as well. What I've always wanted to do and what I have been doing in the past is putting a text-based language on every every MINDSTORMS brick that's been released. So for RCX, I developed PB Lua, which was PB Forth, which is a Forth-based programming language. For the NXT, I made PB Lua, which is a Lua interface for the NXT. For EV3, of course, we pushed the whole, real all singing, all dancing Debian Linux on that. And here, the happy accident of being able to put MicroPython on a brick was just too good of a match to pass up. And I've always been an advocate of people being able to kind of open things up and hack things if you want to. And what we've done here with Spike Prime is given adults or kids, but hopefully kids, the ability to get familiar with, gain confidence. That's one of our main goals here, is to make Spike Prime a really accessible and confidence building tool for kids to learn coding. Once you're happy with what you can do with Scratch, if you choose to, you can lift the lid and really go full steam ahead with Python.
So it's kind of interesting that you were an adult fan of Lego. You were messing around with this stuff. You were doing things with PB Forth, PB Lua, bringing a full Linux distribution to the EV3. You would think that in the past, a company would not say, you should work here. They would probably send you a cease and desist and say, hey, knock that off.
Yeah, and that's that history goes all the way back to the RCX. Myself and a few other fans that were kind of a little more intense than most fans, I guess, hacked the RCX. We completely reverse engineered the code for that. And I met some of the original designers of the RCX at one of the first MIT Mindfests. And when we showed them the source code that we had and reverse engineered, it was one of those, this is actually almost nicer than ours. It was a one-for-one disassembly, but with all the comments and everything that we'd put in, it was pretty much a one-for-one. So at the time, I don't think Lego really was, how do you want to say, in a cease and desist mode. They were kind of happy to see fans getting so much energy, and when they realized the positive buzz that the fan community was delivering, they just said, you know what, go nuts, do what you can. Just don't use the Lego name in whatever replacement firmware you produce.
I really think that's great, and I love that Lego is that kind of progressive and that forward-looking, because they understand that this isn't hacking to break things. This is hacking to make things better. And then when you have like you said, the happy accidents, if you start bringing these higher level languages to these systems, now you've got MicroPython on a Spike Prime, and you're really encouraging people to pop the hood. You say, if you want to use our regular tools, that's great. Otherwise, plug it in. It looks like a USB drive, and MicroPython just lets you save a text file into a folder, and suddenly you feel at least like you're at the low level.
Yep. Actually, just a quick correction. We took away the USB drive. It just looks like a serial port. So you just get a terminal as a COM port. Yeah.
Okay.
I know the regular Pi board has the USB file system on it, but for us that was a little bit too risky in terms of if you unplugged it at the wrong time, you could completely bork the file system. So we've got Little FS, which is another open source file system that's used, and that's pretty much power safe and redundant.
That's really smart, and we should actually juxtapose those things, because in MicroPython and in CircuitPython, you plug in these machines and they look like a file system, but you're right. If you surprise release or surprise remove, you could potentially get into trouble. But with something like Spike Prime, you really want it to be reliable for the kids at all times. They shouldn't be able to brick their brick.
Right. Yeah, and we do have there's always a fail-safe, so you can't actually brick it. So that's good news. You can replace firmware, and if it's a bad image, you can always get back to the default.
Mm-hmm. What is are there any kind of ways to interoperate? Like we have a bunch of EV3 stuff. We have a bunch of existing elements and NXTs. I realize that we probably can't interact from a software perspective, but is there any thought about like reusing motors or bringing any motors forward?
Yeah, that's a great question. So EV3 and NXT use a kind of a modified RJ11 jack for their motor and sensor connections. And with Spike Prime, we're now on what's called the powered up connector platform. So that means that all of the recent Lego components or Lego elements, such as the train motor and the LEDs and the motors that are available from the newer Technic kits, those all will fit in with your Spike hub. That's
fantastic. So
it is awesome.
That is amazing. Wow. Because I want to be able to deal with my existing investment, but I also want the children to be thinking about other things. Like, what is the thing beyond Spike? Is it something that is a Lego product, or is it something that's more traditional motors and microprocessors, a Raspberry Pi?
Yeah, well, so just to be clear, your EV3 and NXT motors and sensors will not work with Spike Prime.
Right.
That's not. But any of the existing Lego components that use the powered up connector do work with that.
Right, the ones that use the newer powered up connector.
Yep.
That are not Spike Prime specific. They're Lego motorized elements.
Yeah, they're just that's the new that if you see that connector, we just call that powered up.
Right. Yes. You see. Okay. I see. Powered up. Okay.
Yeah.
Appreciate that. I was curious. Actually, I wanted to back up a little bit. The EV3 dev project that you founded, I think, is significant because it's a full Linux distribution for an EV3.
Yeah, it's basically a full Debian distribution. So you can do internet. I mean,
How is that possible?
Well, it's an ARM9. There's 64 megs of RAM, which is a lot when you think about it. Compared to some things, isn't maybe not much anymore. It's probably your router has more RAM in it than that, but it's enough to actually get things going. We've got full Python image processing. You can hook up an old USB Lego camera to the EV3 and take screen grabs, or actually take selfies with that. There's people that have done that. There's been projects for radio streaming, like from the internet. There's all kinds of IoT applications for it. It's really, really awesome. And I think there was a competition recently with integrating the EV3 with Alexa. So it's a pretty awesome system.
And what's really exciting about that for folks that maybe are thinking about getting a Spike Prime, but they've already got EV3, it's not actually firmware, right? You can put an SD card in, you basically dual boot. You try out your the EV3 dev, and then if you don't like it, you pull out the micro SD card. There's no flashing of that EV3.
That's correct. Yeah.
Yeah, that's really significant. So in the Spike Prime space, is this meant to be the next generation of motorized and computerized Lego things, or is it a shoot off? How do you think about the generations of those things?
Sure. Well, Spike Prime is part of the Lego learning system, so that's part of Lego Education, which is separate from the retail side of the business. Mm-hmm. But again, it's completely compatible with any of the retail elements.
So we're all sequestered at home right now, and I've got kids. You might be able to hear them causing trouble outside right now. The Lego Spike Prime set, it's really focused on education. Even though we're home schooling at this point, I can go and buy this at education.lego.com.
Absolutely, you can. Yep. And I think that's it's kind of a happy coincidence. Well, maybe it's not a happy coincidence that we're in the middle of this kind of lockdown, both in the States and here in Denmark. But I think it's a great opportunity to reconnect with your kids and their kind of day-to-day life, and an opportunity to for everybody, I think, to kind of learn deeply. If you've had a thing that you've not been able to do because you've got a lack of time, this is a great time to actually dig deep a little bit and do some learning and do some developing.
I'm trying to keep them off screens. Now, they'll be on an iPad and they'll be working with the Spike Prime, but they won't be at least playing Fortnite. So that makes me happy.
Yeah, well, that's the other part about Lego. It's a fantastic building system, and it's extremely well thought out. So you'll find that the construction that you can do with Spike Prime, it is super easy to put together a two-wheel bot and start moving around. But if you want to add, extra actions like a ball thrower or something like that, you can. And there's all kinds of resources on the web that you can find that help you kind of explore and give you inspiration for building new things. The main thing that Spike Prime gives kids, I think, and parents too, is it's an approachable, discoverable, confidence building system. Mm-hmm. It doesn't look scary. There's 3 buttons plus the connect button on the top. There's no menus. There's no fancy screens or anything to look through. It's basically you hit the left and right button to select, swipe left and swipe right to pick which program number. Press the big white button in the middle and then go. It's a go. And
kids already know how to use their iPad, so they're basically moving around Scratch-like elements on an iPad or on a tablet or PC, and they're in order to interact with it unless they choose to do it in a textual mode, right?
Yeah, but it is Scratch.
It is Scratch.
Real Scratch.
It is real Scratch. So it's MIT Scratch.
Oh yeah, it's MIT Scratch.
So what is that relationship between MicroPython and Scratch? Is it a mode? Is it a switch?
That's a great question. So underneath, we actually transpile. Transpile. If you want to start making portmanteaus, you can transpile the whatever the Scratch blocks are translated into actual pretty dense and hard to read Python. You wouldn't, if you were to program the robot in Python, you wouldn't do it that way. But it gives the app a way to manage feedback from the motors, and so your screen gets updates and all that. But yeah, it translates the Scratch blocks into Python code.
Ah, interesting. So you just said something, you kind of threw it out there casually, but you said it gives the app a way to update the screen. You're actually doing kind of aspect-oriented programming where the person expresses their intent, move the motor, but you're injecting other lines of code around it so that it might update itself before and after events so that it's completely instrumented code.
Yes, it is.
Ah, interesting.
It's pretty cool. I mean, when you get a chance to play with it with your kids, I think you'll be arm wrestling for it for the rest of the day.
I'm looking forward to it. No one wants to manage databases if they can avoid it. That's why MongoDB made MongoDB Atlas, a global cloud database service that runs on AWS, GCP, and Azure. You can deploy a fully managed MongoDB database in minutes with just a few clicks or a few API calls. MongoDB Atlas automates deployment, automates updates, handles scaling, and more so that you can focus on your application instead of taking care of your database. You can get started free at mongodb.com/Atlas. Now, if you're already managing a MongoDB deployment, Atlas has a live migration service, so you can migrate it easily with minimal downtime and then get back to what matters. Stop managing your database and start using MongoDB Atlas. I'm curious also, there are add-ons. So if you get to the idea that your classroom or your kids may be somehow outgrowing it, there's this LEGO Technic large hub for Spike Prime. So it's a way to extend it even more. You add this brick and you get input and output supports for even more stuff.
No, the LEGO Technic Large Hub is the standalone. That's just a standalone component that you can order. That comes in the original kit.
Oh, interesting. Okay, well, hang on a second. So the hub is that's the brain, that's the heart of it, right? That's the left-right buttons. You've got your light matrix, 5x5 graphics. You've got Bluetooth, you've got your gyro, and you've got your USB support. And it says you can use that with the Technic elements that you mentioned before. So I see. So that's the heart if you wanted to buy that. And then if you wanted more, you would buy the expansion kit to the Spike Prime.
Yeah, so the Spike Prime box, as you see it, also comes with 2 medium motors, 1 large motor, a color sensor, a really awesome color sensor, actually, that gives you everything from standard LEGO colors, or you can put it in a mode called HSV, which gives you hue, saturation, and value. That's pretty cool. We've got an ultrasonic rangefinder, and there's a force sensor that measures from 0 to 10 newtons of force. And then the expansion kit that you're seeing there is really for kids that are going into FLL type competition. So it gives them an extra motor, some bigger wheels, bigger gears, that kind of thing.
Ah, okay. Actually, speaking of the color sensor stuff, one of the most fun things, and I think the culmination of our EV3 experience, of course, as with everyone, is to create a Rubik's Cube solver.
Yeah.
All right. Yeah. I'm sure you've made those before. And, being able to actually put it blows minds. Like, it's absolutely amazing to go and put a Rubik's Cube into an EV3 harness and have it solve the Rubik's Cube.
Yeah, that's pretty amazing. I think the Rubik's Cube algorithm actually runs on a PC, but all the moves and everything are executed on the EV3. No. Oh no, this one, I'm sorry, the one you've got is the one with the solver is actually on the EV3.
50-page PDF, and it took us a week to do it, and it's really slow. Like, it works hard because it's a big, you're trapped deep in double for loops. It's quite amazing. It's written entirely in the EV3 language, which gets me to my actual question there, which is, what is the most impossible thing you saw that someone built with Spike Prime, where you said, I did not think this would be a thing that anyone would be able to do?
Well, Spike Prime's only been out since January. So,
right, but you've been doing stuff internally. Like, you're all hacking on it. You're all playing with it, right?
Yeah.
Is there a robot walking around in the hallways there at LEGO that we...
no comment. But no, I mean, we do have some internal build competitions. But honestly, it's been such a frantic race to get this thing out the door that we do play with it. There's a couple of things like balancers, like Segway kind of robots. We've seen those.
I guess you could do a Segway, couldn't you?
Yeah, sure. There's color sorters. There's robots that can sort your bricks by color and that kind of thing. So I'm really excited to see what the fans come up with over the next few years. We've got, if you look at the EV3, some of the models that fans have built there are just mind blowing. We've got one that's actually the most impressive one I've seen has 2 Pixie cams attached to the EV3, so it's getting a stereo image grab, and it's estimating where a ball is in 3 space, and you can actually throw a ball at it, and it'll move and catch the ball. It's completely mind-blowing.
Wow. Yeah. And, it's interesting. Those things take a while to kind of marinate in the community. Like, they put a thing out and someone achieves something and you go, wow, that's it. The Rubik's Cube sorter was the pinnacle. And then a year goes by and someone says, well, what if we did? And then the stereoscopic vision thing goes, and I'm sure no one ever conceived that there would be like a 3-space capable Lego element.
Well, yeah, and that's the coolest part about being able to inspire. One of our missions or our statements is that we want to inspire and develop the builders of tomorrow, and we love it when kids and adults use our elements in ways that are completely unanticipated. That's kind of what innovation is, right? It's combining known objects and known materials in unexpected ways. Mm-hmm. And when fans, when they do fancy mocks or my own creations, for people that aren't familiar with the acronyms, they combine elements in ways that we have no idea would ever be used. And we really love seeing that with technology elements too.
Mm-hmm. When you say, you said Lego Mock?
Yes. MOC, my own creation.
My own creation. So we've got adult fans of Lego.
Yeah.
AFOL, we've got my own creation. And then the Lego Ideas has been another interesting thing where a lot of innovation. It was such a progressive thing for Lego to do, to say, all right, you all want us to make these? Vote. Put your vote where your mouth is.
Yeah, no, I think that's been a really fantastic program. There's been some great models that have come out of that. Everything from the space station, the Saturn V rocket.
I've got the women of NASA right over here, actually.
I've got the women of NASA, too. And I've actually got mine signed by 2 of the ladies, yeah. Margaret Hamilton. I've got Margaret Hamilton.
You have Margaret Hamilton's signature?
I have, goodness. I know. It's that photo. Actually, it's funny. We talked about a little earlier about people that have inspired us, and for me, as a young engineer, that picture of Margaret Hamilton standing next to this giant stack of printouts, that was for me. It's like, wow, that is pretty cool. There's a lot of neat stuff happening on rockets and lunar excursion module. Yeah, so that's actually kind of interesting. The original yellow RCX by Lego, it actually had more compute power than the computer that was on the LEM, which is mind-blowing, right?
So, let's just drink that in for a second, because that really tells us how things have been moving forward. Like, RCX was how long ago?
Just over 20 years ago now.
Okay, so 20 years ago, there were Lego elements that we could use to teach children how to code that had more power than the machine that took us to the moon.
Yep. And that's completely mind-blowing when you think about it. Little known fact, the memory in the LEMs was rope core memory, magnetic rope core memory. And they actually hired ladies that were knitters and sewers and crocheters to thread the magnets into the magnetic core memory. So reprogramming it actually meant, knitting effectively a new memory space for that. It's completely mind-blowing when you look at the technology, and it all done in 10 years? Crazy.
While we're geeking out about being old, I was at Bletchley Park, and I was there on a random Tuesday with my buddy, and there was nobody there. It was just a Tuesday at 1:00, and it was quiet. And I happened to be there with some of the veterans and some of the older folks, and I think they were probably upwards of 90 years old, sitting there with an Enigma machine and the Bomba behind them. And he didn't have anything to do, right? He's 90, he's volunteering. And he's like, hey, you want to see something? And we sat there and we talked to this guy for 2.5 hours. He did a complete encryption run, showed us how the Enigma worked, did it, cracked it on the Bomba, and we sat there and we did like Hello World on an Enigma with an actual, a person who knew every bit, every button, every wire. It was absolutely extraordinary.
That's amazing. That is absolutely amazing.
Yeah. I really hope that my kids, particularly I have a 12-year-old and a 14-year-old, as they have been exposed and marinated effectively in Lego for their entire life, will be able to take these kind of things and realize that these are really embedded systems. Like this is a full-on legit embedded system, like the ones you worked on at GE.
Yep. You know what? That's one of the really amazing parts for me is when I see kids, whether they're programming in Scratch or Python, the minute you get a kid to write a program that turns on a motor, turning on lights and setting pixels, that's pretty cool. But when you can turn on a motor, drive your robot where you want to go, and set then the next step is, okay, well, I'd like to make it stop on a black line. So you put a line of black tape on your table, you run it forward, you write a little loop that constantly looks at your light sensor, and I want to stop when I get to black, when I see black. And they're like, oh, wow, that's really cool. What can I do next? So they're automatically kind of drawn into, what can I do next? Oh, if I can stop on a line, can I follow a line? Right. So it's a really, it kind of never ends, right? Mm-hmm. It really never ends where you can go. And I know you talk a lot about where, in computer education, where do I need to draw the line? How far down do I need to go? And I'm guessing that's one of your next questions.
Well, because that's the thing that I find so fascinating is that there is value, I think, in knowing how to drive a stick shift. But there's also value in accepting the fact that the Uber driver knows how to handle this car. But I still enjoy taking it apart and understanding what's going on. So I think there's different kinds of programmers. There's ones who want Lego elements, and they will build amazing things with them. And then there are those who want to know, well, wait a second, how did you make the Lego element? What's the plastic made of? What's the metal inside of this device?
Well, we have a couple of ways of thinking about that at Lego. And one of the ones that I find most accessible is low floor, high ceiling. So what that means is that for kids and adults that want to get involved with Spike Prime or any Lego technology components, the floor should be low. You should have a very low step to get started. Mm-hmm. But once you're in the room, the ceiling should be super high so that no matter how far you want to go with it, you can take it there. And that's why I like the kind of layers that we have. We've got Spike, which is accessible, and you can usually get 95% of the things you want done. You can get that done in Scratch. Mm-hmm. If you want to then take the lid off and program in Python, you can do that too. So it's again a system that can build confidence not because it's hard to fail, but because it's it's pretty easy to write programs that don't work, right? Or that don't perform as expected. What the nice part about Scratch is the programs don't crash. So it may not do what you wanted it to do, but you can usually reason if you build it up from small enough pieces and systems. I know it's another thing that you're really in favor of is systems thinking, is don't try to build the whole robot at once if you've never built a robot, right? You want to, first of all, can I turn on one motor? Can I control the speed? Can I move it forward and backwards? Awesome. Now can I do that with two motors? How do I make the robot spin? How do I make it move forward and backwards? Okay, now I need to add a light sensor. Now I can add a touch. So just start building up your capacity or capabilities and also build your confidence. And that to me is the the really big thing about Spike Prime is it's just accessible, buildable, and a really good confidence builder for young people.
Yeah, that sense of confidence. I know it's a cliche word, but I always talk about empowerment. The idea that I can influence the world around me, that I am not just a kid. I'm a maker, I'm an engineer. I did that. I told it, I commanded it what to do, and it did that thing. Now what else can I do?
Right. And I built it, right? I took familiar Lego elements and I combined them in the ways that I had control of. And then I made a robot do what I wanted it to do.
Mm-hmm. My 12-year-old is already trying to figure out how to make an alarm. So if the 14-year-old comes into his room, that he'll be notified. So he wants a burglar alarm.
Well, he's going to love the ultrasonic sensor then.
Fantastic. So the Spike Prime is primarily for kids 6 to 8, but really any age is appropriate. And it is, again, compatible with LEGO Boost, LEGO Technic sets, some of the classic LEGO pieces. And you can go and check it out. It is shipping now at education.lego.com. I really appreciate you chatting with me today, sir.
Hey, that's been great. Thanks very much, Scott.
We've been talking with Ralph Hempel from LEGO Systems. This has been another episode of Handsome Mix, and we'll see you again